Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at operations with fractions. So we're going to look at multiplying, dividing, adding and subtracting fractions. We'll start with multiplication because it's probably the easiest. When you multiply fractions, you simply multiply numerators, so the top numbers, and you multiply denominators, the bottom numbers. Now you may need to cancel first. I'll show you what I mean by that in an example. But for something like 3 over 4 times 5 over 8, it's nice and simple. You simply multiply the tops, 3 times 5, multiply the bottoms, and you're done. Now be aware that in maths, of means multiply. So 2/3 of 27 means 2/3 times 27. Now when you're multiplying or dividing by a whole number, write that whole number over 1. Because remember, this line just means divide. So 27 is the same as 27 divided by 1. So this will be 2 times 27, which is 54, over 3 times 1, which is 3. So 54 divided by 3 is actually just 18. Always simplify if you can. So looking at this one here, we might do 26 times 35 and then 63 by 39, but that's quite challenging without a calculator. So when you have big numbers like this, always see if you can cancel first. Now when we're cancelling, we're seeing is there anything on the top and anything on the bottom that share a common factor. If there is, you can divide top and bottom by that common factor. So for example, 35 and 63 share a common factor of 7. So I can divide something on the top by 7 as long as I divide something on the bottom by 7. This will make it so much easier for us. Similarly, 26 and 39, they have a common factor of 13. I can divide something on the top by 13 as long as I divide something on the bottom by 13. So doing this makes our life so much easier. Rather than doing 26 times 35, I just have 2 times 5. And rather than doing 63 times 39, I just do 9 times 3, 27, nice and easy. So just remember when you see this little 2 here, it means squared to the power of 2, it means you times it by itself. So 7 over 8 squared means you take 7 over 8 and you times by itself. So that'll simply be 7 times 7 over 8 times 8. So when you're dividing fractions, you flip the second fraction and change the divide to a multiplication sign. So for this one here, 2 over 11 divide 3. Remember, if you're multiplying or dividing by a whole number, write it over 1. So now what I'm going to do is leave the first fraction exactly the same. I'm going to flip the second fraction and I change the divide to a times. So it's just 2 times 1 on top, 11 times 3 on the bottom. We are done. So what about this one here? 44 over 45 divides 66 over 81. So what I'm going to do is I'm going to keep the first fraction exactly as it is. I'm going to flip the second fraction and make it a times. Now we have the same problem we ran into earlier. We have some big numbers here. So rather than trying to do 44 times 81 without a calculator, let's see if we can cancel. Is there anything on the top and anything on the bottom that share a common factor? Hopefully we can see 44 and 66 are both divisible by 22. 44 divided 22 is 2, 66 divided 22 is 3. Similarly, 45 and 81 are divisible by 9. 45 divided by 9, 81 divided by 9. See, we've made it so much easier on ourselves. Now we can actually cancel again. There's nothing wrong with that at all. 3 goes into itself once, it goes into 9 3 times. So on the top, I just have 2 times 3, which is 6. And 5 times 1 on the bottom is 5. So it's 6 over 5. We learned how to convert to mixed numbers in a previous video. 6 divide 5. 5 goes into 6 once with 1 remainder. And that's our final answer. All right, let's now look at adding and subtracting. So unfortunately, people usually find adding and subtracting fractions more difficult than multiplying or dividing because you can only add or subtract fractions when their denominators are equal. So when you have something like 7 over 12 minus 5 over 12, it's nice and easy. You only add or subtract the numerators, the top numbers. So I go 7 minus 5 equals 2, but I don't go 12 minus 12 equals 0. Lots of people make that mistake and it's wrong. In fact, if you had 2 over 0, it's undefined. It doesn't work. When you're adding or subtracting, you leave the denominator the same. So this would be 2 over 12. Now, always check if you can simplify your answer. We can easily simplify this because 2 and 12 share a common factor of 2. So divide 2 by 2, divide 12 by 2, you're left with 1 over 6. That's my final answer because it's simplified. If you just write this, it's not wrong, but it's not fully correct because you didn't fully simplify. All right, let's try 3 over 14 plus 1 over 5. Well, I said before, you can only add fractions if their denominators are equal. So what do you do if their denominators are not equal? We need to use equivalent fractions. I need to find a fraction equivalent to this and one equivalent to this that have the same denominator. So what I'm going to do is I'm going to multiply top and bottom here by 5. So then I get 3 times 5 is 15, 14 times 5 is 70. I'm going to multiply for the second fraction top and bottom by 14. See, in multiplying top and bottom by the denominator of the other fraction, I ensure that I end up with 2 fractions with the same denominator. So 1 over 5 is the same as 14 over 70. So now I am adding 2 fractions with the same denominator. Nice and easy. You simply add the tops, the numerators, and you don't add 70 and 70 because when you're adding or subtracting fractions, denominator stays the same. And we're done. All right, let's now look at operations with mixed numbers. So if you're adding, subtracting, multiplying, or dividing mixed numbers, first change them to improper fractions. So for this here, I'm going to change this and this into an improper fraction. So for 1 and 3/5, remember we take the whole number part, we times by the denominator, add the numerator. 1 times 5 is 5, plus 3 is 8. You always keep the same denominator. 2 and 3 over 16. I'm going to convert that to an improper fraction. I go 2 times 16 plus 3 is 35. And then I always keep the same denominator. So I'm going to multiply these two numbers together. 8 times 35. Okay, that's quite big without a calculator. Can we simplify? Absolutely. 5 goes into itself once, goes into 35 7 times. 8 goes into itself once, goes into 16 twice. So what we end up with here is 1 times 7 over 1 times 2, 7 over 2. To convert that to a mixed number, 2 goes into 7 3 times, remainder 1 goes up here, always keep the same denominator. All right, let's look at this one here. So I have 2 mixed numbers. My first step is to convert to improper fractions. So 2 and 9/10, I go 2 times 10 plus 9 goes on top, keep the same denominator. 1 and 11/12, 1 times 12 plus 11 is 23, keep the same denominator. Okay, I now have to subtract fractions, but they have a different denominator. So I need to make them have the same denominator. So the lowest common multiple, the lowest number divisible by 10 that's also divisible by 12, if you don't know, go up multiples of 12. 12, not divisible by 10. 24, 36, 48, all not divisible by 10, but 60 is. The lowest common multiple of 10 and 12 is 60. So I'm going to multiply this by 6 to make its denominator 60. I'm going to multiply this by 5 to make its denominator 60. What you do to the bottom, you must do to the top when it's equivalent fractions. What you do to the bottom, you must do to the top. So I have 29 times 6. So that might not be easy for you without a calculator. To times by 6, you times by 3 and then double it. I get 174. 10 times 6 is 60. 23 times 5 to times by 5 quickly, you times by 10, so 23 times 10 is 230, you divide by 2, so it'll be 115. So I get 174 over 60 minus 115 over 60. When you're subtracting fractions with the same denominator, you subtract the numerators and you leave the denominator the same. 59 over 60 is our final answer. All right, let's look now at a worded problem. So in a school of students, 3/4 born in Australia, 1/9 born in Ireland, what fraction of students were neither born in Australia nor born in Ireland? Well, let's figure out the fraction of students that were born in Australia or Ireland. So this is the fraction born in Australia, this is the fraction born in Ireland. Let's add them together and we'll find the fraction of students either born in Ireland or born in Australia. So we're adding fractions, they have a different denominator, so we need to make the denominators equal. I'm going to times top and bottom here by 9, top and bottom by 4, so that these fractions do have the same denominator. So 3 times 9 and 4 times 9, 1 times 4 and 9 times 4. So I have found an equivalent fraction to this, an equivalent fraction to this that have the same denominator. We want to do that when we're adding fractions because we can only add fractions if their denominators are equal. Now their denominators are equal, I simply add the tops, 27 plus 4. I don't add the denominators. When you're adding fractions, denominator stays the same. So 31 out of 36 students were either born in Australia or Ireland. So the number that were not born in Australia or Ireland, therefore it would be 1 minus 31 over 36. Well, 1 whole is the same as 36 over 36. So again, I'm subtracting now. I need denominators equal. Now that they are, I simply subtract the top and I leave the denominator the same. The final answer is 5 over 36. 5/36 of the students were not born in Australia, also not born in Ireland. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.